Hey guys, in this video we're going to be starting 7D.2. Our mastery learning objective is I can solve for the missing angle of a right triangle by setting up a trigonometric equation. So in order to solve for a missing angle, you have to use the inverse trigonometric ratios. So inverse is you can still use your calculator, but as you can see here, if sine of A equals 0.5, then the way that you would do is you're basically trying to get rid of this sign on both sides, which, just like adding something, the opposite of that is subtracting, or if you're multiplying, the opposite of that is dividing. The opposite of a sine would be inverse sine. So what we're actually going to be doing then is writing sine inverse, and the way you write the inverse is you write an exponent of -1, and then you're going to have of 0.5 is going to equal A. All right, so by taking the inverse of sine of A, you're just left with that angle, okay? So therefore, the way that we use our calculator, you're still going to use that trig button, but instead you're going to use the sine, which means you have to go down and use the inverse function. So sine inverse of 0.5, and again, always making sure you're in degree mode. I'm already in degree mode, and that's going to give me 30. Therefore, my A is going to equal 30. I wish I would have wrote this a little bit smaller for you guys. All right, let's try another one. So we see cosine of A equals 0.5. So again, I'm looking for this angle. So I have to do the opposite of cosine. The opposite of cosine would be taking the inverse. So that's going to mean that our cosine, inverse cosine of 0.5 is going to equal A. So now I'm going to use my calculator, trig, I want to go over down to inverse of cosine, type in 0.5, and I'm going to get 60. So A here is equal to 60. All right, last one here, our tangent, same idea, I'm looking for my missing angle. So I have to do the opposite of tangent. Opposite of tangent would be inverse tangent of 0.5 is going to equal my A. So tangent, inverse tangent, 0.5 equals 26.57. So our A here is going to equal 26.57. All right. So that is what we're going to be using to find our missing angles. You do the inverse of whatever ratio you have there to find whatever angle we're looking for. So looking at example number 1, already looking at what we have. This is my theta. Obviously that's unknown, but from my theta, I see that this is my opposite side, and that's my hypotenuse, which makes this my hypotenuse. And the only things that I have here are O and H. So again, using our trig ratios, our SOHCAHTOA, the only one that has O and H is sine. So that's what I'm going to set up. Sine of theta is going to equal O over H. Right? So therefore, my sine of theta, right, because I don't know what my angle is, but I do know that my opposite is 1.4 and my hypotenuse is 2.1. All right, so by doing that, I have to take the inverse of both sides because what I'm looking for is my angle. So by taking that inverse, that's going to give me my theta. The inverse of sine would be inverse sine of 1.4 divided by 2.1. All right, that is what I'm going to go ahead and substitute in my calculator. So trig, inverse sine of 1.4 divided by 2.1. All right, that's going to give me 41.8. 41.8. We can do 8.1, keep it 2 decimal places. And this is an angle, so therefore I do need my degree sign. Our previous video was finding the missing sides, so those are not measured in degrees. That would be whatever unit we measure our side lanes in. All right, looking at the next example here. According to my given angle, this would be my opposite side. This is across from the 90, so that's my hypotenuse, and this is my adjacent side. So the two sides that I do have are my hypotenuse and my adjacent side, which would be O and H, and that's going to be our cosine. So cosine of theta is equal to the adjacent side over the hypotenuse. Substitute what we have. Well, we do not have our given angle, so I'm just going to write theta. My adjacent side is 2, my hypotenuse is 3. In order to find my angle, I do the opposite of cosine, which would be the inverse cosine. So theta is going to equal inverse cosine of 2/3. And I'm going to plug that into my calculator. So inverse cosine of 2 divided by 3 is going to equal 48.189. So I'm going to round my answer using 2 decimals. So 48.19 degrees. Again, when you're working on these problems, please just pay attention to the directions. It'll tell you, to the nearest degree, so whole number, 1 decimal, the tenth, the hundredth place, so just pay attention to whatever it's telling you to round to. All right, scrolling on down to our last 2 examples here. Same idea, right? I find my given angle. I know this is my opposite of that angle. This would be my hypotenuse, because that is across from the 90-degree angle, and this would be my adjacent side. So the 2 sides I do have are O and A, which is tangent. So tangent of theta equals our O over our A, opposite over adjacent. Substitute what we know. Well, we do not know our given angle. Our opposite, however, is 14, and our adjacent is 19. I want to get rid of the tangent, so I do the inverse of tangent, which is going to give us our inverse tangent of 14 over 19. And that's going to give me my theta to be inverse tangent, 14 divided by 19. And that's going to give me 36.384. So this would be 36.38 degrees, because this is an angle. All right, last example here. This is my opposite side. This is my hypotenuse. So O and H would be our sine. Sine of theta equals O and H. So sine of my missing angle theta. Our opposite is 13. Our hypotenuse is 21. I want to look for that angle, so I do the inverse of sine. The inverse of sine is my theta. Keep writing that backwards. 13 divided by 21. I'm going to go ahead and plug that into my calculator. So sine inverse 13 divided by 21 equals 38.25 degrees, and that is my missing angle. All right. So again, when you're looking for missing angles, you're going to use the inverse functions. When you're looking for missing sides, like in our D1 activities, that's when you just use normal trig ratios and solve for your x. So be very careful. Pay attention to what sides are and what angles are and what you're actually looking for. All right. Good luck.